Welcome everyone. We are going to start the conference of today. Today we have here Larysa Globa, that is a professor at the KPI in Kyiv, and she is an expert on facile logistics, and today she is going to present us her current research. So when you want, you can start, and we are going to share the screen. So first, okay, I think we are going to share all the screens, right? And now, here it is.
This is not first presentation. My first presentation was.
Probably we close.
Close, yes.
Oh, we close. Sorry.
Shall I start?
Don't worry. I think we close.
Maritza, probably Igor prefer to start.
You prefer to start?
I can start, yes, but
Wherever.
don't worry, she has been presented, so now she start.
This is the presentation, right?
Who start? I'm started.
Yes, you can start.
Okay, dear colleagues and students, I would like to present our research in fields of artificial intelligence methods connected with some practical usage of artificial methods for make the decision different tasks. For the first, I would like to speak about big data. Today, we understand that everything is in digital environment. According to this, big data became more and more important. We have internet-based services. We have e-commerce. We buy everything via internet. We have education via internet, and so on. According to this, we have a lot of data today in internet storage, but new technologies such like Internet of Things became new impact services which give us a lot of new data and needs new techniques, new algorithms, and new understanding how to use this data. According to this, we can speak about big data, about volume, velocity, variety, veracity, value, and so and so. And today we speak about V in N. A lot of data we have, and a lot of problems arise from this data. What to do with big data and how it processing? For this, we suggested well-known already approach, but important. From data, we should to get information. From information, we should to get knowledge, and based on the knowledge, we should to predict next situation, next understanding of our situation, of our problem area, what will happen with this. If we speak about traditional method, data analytics, we have a lot of different algorithms, but you can see on the slide this algorithm, but this algorithm give us possibility to specialize for different type of the data, and they give us possibility to make a decision to predict a further situation, but it's need to understand what algorithm is better for some subject area. it's very important today because we have a lot of data. Each algorithm have own time for processing and possible to process different kind of data. One, for example, processing with picture, another kind processing with signals, another kind processing with simple data, and so on. According to this, we need new algorithm and need new understanding how to processing a big data for the different subject area. We know statistics, machine learning, artificial intelligence, and this algorithm involved today for big data processing analytics. We suggested a general approach. We tried to use general approach for problem solving based on the fuzzy logic rules, especially for IoT system, because it's such approach characterize not big complexity, computational complexity during data processing, but need some computational resources for preparing fuzzy logic knowledge base. But this two-stage it's possible to divide it in two processes. First process to study the subject area, to study the situation, and form fuzzy knowledge rules, and after that formed fuzzy knowledge base, and after that to use fuzzy knowledge base for recognizing and learning with help of the machine learning algorithm and metagraph theory, and get fuzzy conclusions and fuzzy prediction. I would like to speak about this algorithm for our research, which we have in our university. General approach we can use in this data stream. We should to functional and sense dependencies instruction from data streams. From getting data, we should to form meta description, metadata, and find the parameters impact rate determination. After that, we have fuzzy knowledge base, and we use metagraph theory for some conclusion based on fuzzy knowledge base, fuzzy conclusions and fuzzy prediction possible to use to get from fuzzy knowledge base. The practical application we would discuss in three subject area: telecom operators analytics, mobility network traffic classification in for 5G networks, and management of road traffic. It's some our research which we have just now. Start with classification. Sorry, just a minute. Start with fuzzy knowledge-based development. Oh, no, sorry. First will be... but where is the... Sorry. Example one, approach to big data processing for telecom operator based on statistics data. Motivation in this field, we can say about a lot of data has telecom operator and good and well developed business for telecom operator based on the understanding all kind of the data. This is the system, infrastructure, network, and technical equipment, and base station, and so on. And this is some management data. For example, how the operator likes the subscriber, and what is the service. Is it subscriber? Is it for them a good service or not very? Is it some problems with services, and so on? According to this different type of the data we could see on the slide, use telecom operator. And for the analytics, it's the operator should to use all this data. And new types of the players which use gives a lot of data for this is load for operator. The new types of the players joining to the industry. This is such like Skype, WhatsApp, ICQ, and so on. Everybody today use the social networks and which produced a lot of data. Some management data so very important because it's need to increase sales, it's need to decrease operational cost, and so on. Some risk management, and some different kind of the business problems should to understand operator. The practical application for telecom operator is faced with urgent need to complex account of different characteristics of provided services. Technical, economical, experience of using services by end user, and they want to clear, understand, and process management that occurring between the operator and its subscriber. This whole range of parameters is too large and complex for the collecting, processing, analysis with the usage of current computational infrastructure. According to this, we have the research motivation. The quality of mobile operator services is usually evaluated by user experience only, because they ask the user about their quality understanding. But this is not enough. Real technical parameters are not taken into account. Only cumulated assessment of all parameters gives the operator real situation and real understanding why the subscriber go off of the operator or would like to use the services of this operator. According to this, how to find an optimal balance between the parameters influencing into subscriber decision. For find the decision for this task, we use such steps. First step, data stream forming, functional and sense dependencies extraction, meta description forming, parameters impact, and determination. Fuzzy knowledge based forming. After that, step 3, fuzzy knowledge base reorganizing and learning to help with help of metagraph theory, and use fuzzy conclusion based on metagraph theory on another way, and fuzzy prediction. This is slide you have seen before, and discuss how knowledge base to form. First example of how to form fuzzy knowledge base, we can discuss about QoS analysis of the service. For the first, we can see on this slide a lot of parameters which technical system of operator. No, this is not all the parameters, it's more, but it's some, like example. Operator has from his infrastructure from his monitoring systems. All these parameters are statistical. These parameters should to be normalized from 0 to 1 because their influence was equal for the model of fuzzy knowledge base. And we have the problem what parameters, how to find the result parameters. We have a lot of parameters from monitoring system, but how to find result parameters, which is efficiency or quality of service, because this is not digital parameters. This is like understanding parameters, which is understanding by expert. Good, not good, is parameters not equal. This is fuzzy parameters. According to this, we should to use some method to understand integral quality index of providing services. We can systemize all input parameters and have no possibility to measure the parameters of quality. We can use for this, we can use the subscriber answer during some questionnaire, and after this we, based on the understanding of expert, we can form these parameters. Example of source data you can see, and algorithm for QoS parameters estimation. We normalize the parameters, input parameters. You can see this already normalized data. We can split measurement table into 3 samples: training, test, examination. Quality index of providing services calculated using the disability function based on data from training sample. Fuzzy knowledge base formation formed used the current values of integral quality index, estimation service quality by telecom operator. For estimation service quality forming, we use the integral quality index of provided services. Normalization is I show shortly because it's a simple formula for this we can use. And splitting table you can see on this slide. And calculation, calculation using the Harrington disability function. This is possible to use expert weighting coefficient or machine learning. The second approach, more flexible, but not use expert knowledge and allows reducing the error probability due to the human factors. And the genetic disability function possible to use for getting Y. This is on this slide. You can see the formula. This graphic shows how it works. And for example, we can see, for example, from 0 to 0.35 is low. From 0.35 to 0.65 middle, and so on. It can be the measure, for example, good or not good services is present, is quality of service can be estimated. And this measure can be done by expert or according the questionnaire, based on the questionnaire. Genetic disability coefficient we can get from this formula. It's more detail you can see on the slide. And if you use information about this mathematical model, and according to this, you can get the digital estimation quality of service like Y parameters. According to this, possible to form fuzzy knowledge base in form of the rules if then, if X one and so on and n, then Y. According to this, we can estimate the Y like digital results, and based on we can get good or not good, very good, and how we need according our classification. This is on this slide and some slide next presented the fuzzy knowledge-based formation algorithm. Initial data X, which is defined on the input area of discourses, and one output Y has one discourses dy, and after that we can get our fuzzy knowledge. Is possible to get fuzzy based on this data, possible to get fuzzy knowledge base. There are many for first step of forming fuzzy knowledge base is clusterization. There are many methods of clusterization, but we use a fuzzy C averages algorithm, which based on distance, minimizing from the observation data to cluster centers. Fuzzy C average algorithm working as follows. We have given observation table, number of the clusters, which is M, and stop parameters epsilon. Fuzzy partitioning matrix F and clustering sentence is matrix V. here you can see this algorithm. This algorithm is one disadvantage. This is disadvantage is we need to know how much clusters we have, but in for the getting the results of clusterization, this algorithm is not bad. He gives us good clusters. But if we don't know how much clusters we have, this algorithm will be need a lot of processing time to find the center of the clusters. This is a part of this algorithm too. And very important is membership function selection. Each linguistic term being antecedent of fuzzy rules is defined by its membership function. And there are several membership functions, triangle, and so on. You can see here on the slide. And if we use this type of the membership function, we based on this this function, we take into account influence of the some parameters which impact in our fuzzy knowledge rules. You can see here. To get some results, quality estimation, we should to obtain integral quality index and for get this index, we need at least one rule for each linguistic term of output variables, and for any terms of input variables, there must be at least one rule where his term is used as an antecedent. There should not be contradiction and correlation between the rules. The rules, each rules should be not in contradictory with, have no correlation with another rules. According this, we need to check our fuzzy knowledge base for absence this possible problems. The step fuzzification is based on the linguistic terms, and on this slide you can see how it works. If we get some results of fuzzy Y number of the digital estimation of the Y, we can get what better, it's low, middle, or high, according to the fuzzy understanding of our results. For getting results, we use some aggregation procedure. Here is the example. For example, if we have such results, we can use minimum results when we use our rules for estimate the situation, and accumulation we should to use when we have some different inference from different our results from different rules, and the falsification we use for getting formed at least exact our fuzzy knowledge rules. According to this, we have the fuzzy knowledge base, which is include a lot of rules, and the fuzzy knowledge base we use for understanding situation, for conclusion, and for prediction. If, for example, we would like to change our infrastructure and include additional equipment, we can have such approximately parameters, and if in this case was the quality of service good or not, improve in such way like we need or not. This is the infrastructure of this is like diagram of our proposed solution. This is accuracy estimation of our solution, comparison with, for example, different methods, statistical methods, and neural networks methods, and we can use metagraph as a way how to predict, for example, and answer the question analysis of subscriber loyalty. For example, we have technical, economical, social parameters for understanding. This is the example of the parameters, example of the economical parameters, and we has such kind of the table with parameters, and according to this we have the rules which we get based on the suggested algorithm and techniques, and using these rules we can form rules for fuzzy knowledge base. This is the same slide about steps which we speak about already, and after that we can form the metagraph. Metagraph is the way how to map every expert rules into the graph, but this graph should have some edge and verticals which is connected each one with another. We have such kind of the verticals which are complex, some include some parameters. It gives us the possibility to represent our results like complex of parameters, and metagraph can correspond with different verticals and has some ways to give the conclusions. This is some. There are some rules which gives metagraph possibility to check the correctness of each and absence some problems with each rule in fuzzy knowledge base. In this slide, you can see that some metagraph is correct. For this, metagraph is incorrect according to the metagraph building rules. Based on this, we can use them for getting the conclusions. We can use some rules connected with force, and attraction, with force of gravity, and we use this calculation for develop metagraph and visualization it in good way. And metagraph we can use like structure for conclusion and extraction. I shortly show because I think it will be, for example, this is on this slide we can see there are no two conclusions from one data. This is not correct. Metagraph not give us the possibility to do so, and not correct ages, for example, and so different problems with metagraph we can check, and after that we can use the metagraph nodes numbering method for getting the results and get the conclusions of the some big number of the data. We can see the part of the data which involve involve with decision our task, and after that, based on this data, we can find the decision, this or this decision, for example. But if we use this data, blue color, we get this result only because this result is impossible. This is some approach to how to use metagraph shows in this slide, and we can see this fuzzy conclusions from different kind of the parameters. And for prediction, we can use the same approach and use the fuzzy knowledge base based on the some prediction input data. No, this is conclusions that use the fuzzy knowledge base techniques give us the possibility to see the future directions and understand the trends based on our infrastructure, based on our management system, and so on. We can find the different decision. This is some for data for telecom operator, some give some possibility to get the best decision. Next, our block of the research connected with traffic classification in 5G networks. In this research, we have would like to understand some traffic data which processing in 5G networks. Is it data good, or is it data from different not correct user, not like forgot the word, like malicious data, like data from bad, some bad networks, like some not correct using this infrastructure. This data we can in the internet we use different kind of the information, and this different kind of information increases the number of resources and the methods of its transmission and processing can be different, and different methods should be involved to processing data. And now we can see that increases the number of the sensor. This is need to defend the data processing, and they need the quality of service and radio access networks, and network core should to be defend from different attack, and it need to classify the data in this especially in radio networks, because data from IoT system should be very strong defense from their changing, from their getting not good part of the who would like to use this network, and it became more and more important task. And according to this mechanism to recognize malicious package, which lead to understand who use the traffic, which aims use the traffic is very important. Intelligent means of traffic processing and classification can help solving this problem for 5, 6G networks, and can be deployed both in edge servers and directly on the base station, because it needs to control on all the part of the infrastructure of operator this problem. So the purpose of research to study efficiently of the artificial intelligence method, in particular machine learning algorithm, to detect malicious traffic in 5G mobile networks. This is important to understand quality, precision, and performance of this algorithm, because this algorithm should be deployed in the base station, in the network. The resources is quite limited, and it can be used very complex methods with big processing complexity. It not use a lot of time. It's not use short time, but it's quite very important to classify the data and to direct this data in different direction, in different resources, and to stop access for not permission users. If we look at the infrastructure of the network, 5G network, we can see that network has a lot of slicing, and each slice is used for different type of the data. According to this, we need to classify our data process, our data package too, because different slice used for different data transfer, and we has the standardization by 3GPP. 3GPP, this network layers to support different quality of service, different latency, and different bandwidth throughput. You can see on the slide different kind of the data, different kind of the user, and now a very interesting device-to-device communication, which should be, which need very strong, very big bandwidth throughput, small latency, very small latency, because if two car change between each other some data, it should be in time, because car has a very big speed, and data should be processing in time. For make the decision of this problem, good quality of service for each kind of the services, the 3GPP used edge computing and mild computing. According to this, the different user of the services, for example, car, should to use some edge possibility, edge computing, for example, light devices and so on. According to this, the main disadvantages is insufficient consideration of the information specific entering the communication network and insufficient adaptation level of existing traffic classification prioritization method to ensure the approach level of quality of service. Lack of adaptation of existing methods to the growth of traffic volumes and the appreciation of new types of load, massive Yehor, V2V, and so on. Insufficient adaptation of the data processing to new threats that arise during implementation of new services and new elements of the network. According to this, it's possible to formulate statement of research problem, multi-class classification algorithm aim to assign a class label to each input instance. As input data, training data set is formed like X eta, Y eta is used, where X eta is the parameters from the input examples area, and Y eta is the ET parameters, ET class label. It's necessary to find a learning model H, such will be presented like this formula for all E of new unforeseen instance. Requirements for algorithm. To choose the algorithm should be corresponded to the formulation of research problem. This choice is not obvious. The experimental studies are needed to each problems. Each algorithm is more good working for some data and not very good working with another data. The main requirements are high values of selected classification metrics, training speed, and prediction speed. We discuss algorithm, Kylian algorithm, which use Manhattan distance or Poisson similarity based on the nature of the data. KNN algorithm is positive integer that specifies the number of nearest neighbors to consider when making a prediction. On this slide you can see this, but very often it gives not very good decision, like this yellow decision. It's not correct decision. Another slide, after training we can see that we have two clusters which give us the decision. Next algorithm is decision tree. We examine next some algorithm. Next algorithm is decision tree. Decision tree used for determining what which attribute is best, Gini, impurity, and information gain. Decision tree is simple, very understandable algorithm, because from our we have the tree. According to this tree, we find our decision according to our data. Here is the explanation of decision tree algorithm, but criteria is one and this one, and information gain this one and this one criteria we can see, and stop criteria has we stop this algorithm when we get maximum depth, having a minimum number of samples per leaf, or in counting per nodes containing only one class. Next algorithm which we examined was random forest algorithm, which instead of building the single decision tree, use it make prediction, build many stringly different trees, and combine their prediction by voting based on the majority votes of predictions, and algorithm predicts the final output. Here you can see the idea of this algorithm on this slide, and here is the steps, and the ADA boost. Next one algorithm was this is about random forest algorithm. Next is VADA boost algorithm. ADA boost algorithm constructing strong classifier as linear combination of simple weak classifier according to this formula, allows subsequent model to concentrate on the more challenging examples, gradually improving the overall performance of this of the ensemble, and ADA boost algorithm considering a data set with n points or row in data set, and assigned weight to each training example to determine its significance in training data set, and the weighted sample always sum to 1, so the value of each individual weight will lie between 0 or 1. For normalization. After that, it's possible to calculate influence of this classifier in classifying data points using this formula. And during the iteration, we get the decision, and this algorithm is needs some times for calculated. According this, it's iteration calculation. According this, it's sometimes it's difficult to use. Gradient boosting algorithm combines weak learners into single strong learner in the iterative function, and by fitting each tree in sequence to previous trees residuals, we are allowing each new tree in sequence of to focus on the previous tree mistakes, and each use some formula for calculating the results, and we can see here the different tree which we can use for different set of the data. And according this, to evaluate the performance of classification algorithm, it's necessary to choose classification metrics for multi-class classification that will reflect to the quality of results. And here is the table with classification metrics which we can use. This is a number of examples that we correctly identify, a number of examples which were incorrectly identified, and number of examples which were incorrectly identified as beyond to class. And this is explanation for this matrix. Matrix is accuracy, precision, recall, F square nu, precision M, recall M, F square M. This is well-known matrix. Thank you so much. And this is well-known formula for using this matrix for quality estimation of the algorithm. And the data set which we used is we get from internet, from the flow data set, which this data set presented the experiment which will be used for the algorithm estimation by our PhD students. And the experimental part, we have some steps for estimation, metrics which we use for algorithm estimation. Model for training was realized, used Python programming language, and we can see the results. For each of the algorithm, it's very important to find optimal hyperparameters with cross-validation techniques. Here you can see the results when each algorithm use optimal hyperparameters. If we can see that the time in second during which the model training predicts data test sample, we have the time training. If we look at time training in this, this is the results without time training. Time training in this table. If we look at the time training of this algorithm, we can see that, for example, here is the smallest time training decision tree, and not big time training for each of the algorithms. But T1 time training, we can see the decision tree has smallest time training. T2 is the prediction time. It's during the predict. You can see that decision tree has smallest time 2. And T3 is prediction time. And we can see that decision tree has smallest time, but another algorithm has small time too. For example, here is KNN algorithm, but it's not so small. It's only 2.0 before. As a result, the comparative analysis showed the best classification metrics can be achieved using XGBoost algorithm. GBM algorithm slightly outperformed the GBoost algorithm in terms of classification metrics, has the lowest prediction time but the longest training time. The random forest decision tree algorithm performed worse on classification metrics, but the decision tree algorithm is the fastest in terms of training and prediction times. Algorithm ADA, Boost, and KNN shows the worst results in terms of classification metrics. This is the second example, and the third example I try to show quicker the fuzzy knowledge base development for management the road traffic. Motivation is understandable because smart cars appears in the road, need to manage road traffic and to try to be on the road without different an incident. For this, we suggested to use fun knowledge base and design fuzzy logical rules like fuzzy knowledge base, and to try to develop intelligent IoT system that decrease the need for computational resources and has a significant increase the traffic intensity, which will be work when we have a significant traffic intensity on the road, on the modern city. We use the characteristic we use the statistical data, time, hour, month, accuracy, speed, and different statistical on the road on the one places, for example, like this, and different. We look at different algorithm. For example, we use Cummins FCM algorithm and discuss about the algorithmic complexity and time spent during the traffic classification and during the time of the traffic prediction and exchange the data between the car. Here is the comparison and the visualization method. We need to visualization method for understand how good this algorithm is working. And according to this, we use the metagraph. It's like more effective methods for this. Fuzzy knowledge-based development, we already speak about pre-cleaning data, data clustering, fuzzy logic rules development, fuzzy logic rules can give no duplicates to cleaning the fuzzy knowledge rules from duplicates and not correct rules. Cleaning data pre-cleaning data, we use some correction missing entities, deleting duplicate entities, deleting irrelevant records, and normalization. Analysis of clustering algorithm. There are some methods according their complexity, time for their working, because very important time of data processing in the when two car very quicker exchange the data. We find the best one, Cummins and FCM methods. Here is the picture which shows how they build the clusters. Each cluster is one rules. This is the example how it working. And very important that this data has, we don't know how many clusters should to be, because a lot of algorithms need to like an input data number of the clusters. In this algorithm, we don't need know how many clusters should to be. Here we can see the the picture how formed the clusters in this slide, and Semins algorithm is effective, but according to the complexity, we use Cummins method because this method gives many, not so many mistakes with class poor find the centers of the clusters. Here is a picture which show how poor will be find the center of the clusters. It's not good. According to this, we use the Cummins method which has no such problems with clusterization. And this is shortly description how this algorithm is working. And next algorithm which can be used together with Cummins elbow methods, which give us possibility to find the number of the clusters. This algorithm use the distance between points, and base of this distance forms the number of the clusters. And this is the short presentation of formula and short presentation of the algorithm. This is the steps of the algorithm. And we use fuzzy knowledge base forming based on the previous our experience, fuzzification use, fuzzy inference, and defuzzification. After that, we get the terms of linguistic variables, which give us possibility to take into account influence of each parameters. This is clustering algorithm description, and you can see some, for example, two-dimensional space, which divided in group of the clusters. And for forming fuzzy rules, we use the triangular function, which give us the possibility to form all variables normalized from 0 to 1 for their influence input take into account. After that, we designing we use Gaussian function to design fuzzy rules. Here is some formula, some explanation with this formula for develop rules in form if-then, constructing a membership function for each linguistic variables, and design the fuzzy logic rules. For designing fuzzy logic rules, we use genetic algorithm for improving the processing of develop fuzzy knowledge rules, and this is the scheme, shows the input data, has the clustering blocks, building fuzzy logic rules, and blocks of formation fuzzy logic rules. And we get such kind of the rules like on this slide. And for representation, fuzzy knowledge rules base, we use the meta graph, where the set of vertices terms, set of the meta verticals, and set of resulting verticals. And if we look at each rules, we can see from this graph, we can get sub graph which present some rules or some conclusion based on the group of the rules. This is time, dependence, processing speed. It's decrease a little bit. Architecture of the system for constructing fuzzy knowledge rules. The system was developed based on the microservices techniques, and this is architecture of data analysis and decision-making system, which can use for estimation the situation on the road in the city. This is conclusions. This is examples of usage. Our fuzzy knowledge based fuzzy decisions for different subject of for different area of subjects in fields of telecom operator analysis data and fields of the estimation the situation on the road. Thank you for your attention. Thank you.
We also have 10 people online, so if anyone have question online, you can share in the chat also.
Okay, there is a question. Thank you for the presentation. Regarding the implementation, did you use what kind of platform did you use for implementing the policy?
Microsoft Azure we use. But now we think about Java platform too, because the services, microservices, microservices is possible to use like components for Java platform too.
Even
We
for
think about
fuzzy knowledge base, you use Azure?
Azure.
For Mandani implementation. Why didn't you use edges in implementation of fuzzy rules? You didn't think that it was necessary, or it could be helpful to add the concept of edge into the rules?
Possible to add maybe, but we not use it. We use rules in form if then,
Yeah.
and some algorithm for different algorithm tested for develop rules, and for decision making we already use algorithm-based metagraph, like decision tree, decision like forest. But just now we think about future work in different direction. But important task we try to find the genetic algorithm for example, for traffic classification. We use already genetic algorithm and find the what is better, fuzzy knowledge rules or genetic algorithm, because we can develop the some for each situation. If we have statistical data, some curve for each part of the curve, we can have the pattern. If we try to training our for this data, we training our algorithm based our algorithm, we training and find the pattern after. In real situation for conclusion and prediction, we can use this pattern. It's not fuzzy knowledge base, it's pattern, but it's need to compare where it's better. For what kind of the data? For example, for if we face recognition, it's one kind of the data. Maybe genetic algorithm will be better than fuzzy knowledge base. But if this statistical data like, for example, quality of service estimation and where there are no such face, each people has more stable face than, for example, exchanging the data transmission via the network. According to this different behavior of the data and different kind of the data and different tasks can use different algorithm. It's not exactly decision, but we look at this task and think about new tasks, especially for IoT system where the sensors and so on data. It's even have problem is, for example, sensors transmit data to the edge node. How long? What is the environment? And so different problem. It's need to change the, but pattern is very important today.
Okay. No questions? I have a question in general, but more oriented to the 5G traffic, data traffic. Are you using real-world data from network stations, or are you focusing on data that
We
is
use
open?
we use open data, but we have possibility to use some data from mobile operator of Ukraine, because my doctor already Dr. Hibil, like doctor of science, but not doctor of science like candidate in Soviet Union was a working in Samsung, and they have some statistical data from traffic which suggested Samsung for study for data, for example, for data traffic classification. we have possibility to use some real data of operator, but they are closed. It's not, we have no possibility to present it, but the result is the same like this, because this sample, which I show on my slide, is very close to this data, which statistical data from real, yes.
Okay, because this should be a first source of collaboration.
Yes. Yes.
Fair system.
It's quite possible to collaborate with Samsung, because we have a good, especially in the fields of defense data and so on. With Samsung, on my chair, we have some person, assistant of professor, who are involved in the working group of Samsung.
Okay. So, thank you.
I have a question. In order to test the quality of the network, in order of traffic, if you have, for example, a time series data set with a lot of parameters regarding the network, for example, which algorithm or kind of algorithm do you recommend to test this quality?
To test the quality, we recommend, I presented the algorithm Kamins plus and elbow for Kamins. All algorithm for clusterization need how many clusters. Elbow get possibility to find the number of the clusters, and after that to use for clusterization Kamins. Each cluster is each rule, and according this, the easy to develop the rule. But if cluster is very if we have very close our data, not but very close, it's possible to, according the fuzzy body, its data is each with other, yes, and it's need to cleaning the fuzzy knowledge rules, and because a lot of rules, it's not good too, because it was not correct conclusions. If we get this verticals and return to not to incorrect another high level verticals. According to this, it's need to, but all the time it's need to relearn, retraining, because data can change in. But this method more effective, according our experience. Thank you.
So no questions? So now we have a presentation of, I don't know your name.
Yehor, Zheliazkov.
Okay, so now
I say some words. This is our PhD students who will define the nearest time he PhD. In this usage, the artificial intelligence and some special devices. He developed the Yehor system for health, for control the health of the people. According to this, we would like to find the cooperation maybe in this direction, because this research will be done together with Dresden Technical University. They strongly help us to present this research because they're interested in, and they cooperate with company who produce some devices can show.
You can also let economists see.
Yes, and according to Germany colleagues, very interesting to cooperate. We think about maybe it's possible to organize based on your health department. You have the hospital, as I know. Is it possible? Maybe is it possible to develop the project, European project, together? Because Ukraine need very need such kind of the research, because you know situation in our country and so on. Everybody need, because every country need, because we would like to have more comfortable living and for people, and especially we cooperate in this direction with cost program, which is develop the environment, comfortable environment for living old people. And some colleagues from Netherlands and from different European countries, a lot of, especially Portugal. I know a lot of conference will be here. Just now will be in Romania conference, cost conference, and they came to involve in such project too. And maybe we find the possibility to organize, especially based on the hospital, because the people, doctors should to consult, should to explain a lot of theory, because we should be based on the real medicine system.
Access or you have to change the computer.
Here not, but
Really do have to
I
see
think
the
I
overlap.
Да.
change the place. So. So, ladies and gentlemen, I would like to represent you a special topic. It's also, as Professor Globa has already told, part of my PhD thesis. The topic is intelligent lighting system for comfortable living of the older people. There are three authors of this work. It's me, Yehor Zheliazkov, PhD student, Professor Globa, and also one of my supervisor at the Technical University of Dresden, Professor Kloss. It was done together with three universities, developed with three universities. It's my home university, Kyiv Polytechnic Institute, Technical University of Dresden, and the University of Oldenburg. For each universities, you can for each others you can see corresponding university. So, motivation of research. People, all people need more healthy control, and it was always actual question of all the time. People regularly stay alone at home, and it doesn't matter whether it's Corona time or it's time when people are not so mobile, not so mobility, and therefore old people use they are sitting for a very long time in front of the monitor of different devices such as computer, mobile phones, and so on, and this breaks disturbances of circadian rhythms of the person. Circadian rhythms is a special determination of sleep-wake cycle, which passes 24 hours per day. For example, we have got the lowest body temperature at 7 p.m. We have got the best sleep time at night since 24 o'clock until the 2 o'clock a.m. And this process describes circadian rhythms. And disturbances of circadian rhythms goes to the deterioration of sleep quality, drowsiness, bad human mood. So one of the main aim is to control the health state of the people based on IoT system. One of the some problems are which kind of physiological parameters can inform about the state of old people's health. The best can explain, and how to control it. So the task of the research is to develop the system of predicting and avoiding instant decreasing of healthy level for older people. So actually there are a lot of different medical signals which can be measured for photoplethysmogram, such as here, electrocardiogram. It's also myogram connected with muscles, oculogram, and connected with eyes, and so on. But after the certain research, it can be found that photoplethysmogram is the best, one of the best signal to receive more information about comfortable and healthy state of person, especially of old person. There are certain parameters which can be used, which are useful for describing the photoplethysmogram. It's the red line, and electrocardiogram. You can see it here. The heart rate, pulse amplitude, pulse transit time, normalized crest time. So, photoplethysmogram. It was found there. There is photoplethysmogram signal, and for each age category, there is certain pulse transit time or when people feels good and don't have any healthy problems. There are three categories: 21-44 years old. You can see pulse transit time of photoplethysmogram. Pulse transit time, it's the interval between P1 and P2. It's for the first category, 21-44, 339 to 359 milliseconds, 45-59 years old, and people more than 60 years old. And on the right side, you can see electrocardiogram signal and photoplethysmogram signal. And PPI interval does it. I'm sorry, not pulse transit time, but this describes pulse transit time. It's part of pulse peripheral time, peripheral interval, from the one peak point to the another peak point. And you can see here that RRI interval is approximately equal to the pulse peripheral interval with a little deviation. It was used also for this research. People can measure photoplethysmogram by a lot of ways. You can see some examples how people can measure with special glasses, for example, with special bed for measuring, with pulse oximeter, and with another different sensors. So, experience of using physiological parameters based on smart lighting system. We have already done 2 experiments in order to define which lighting is more comfortable for person and which light is more useful or less useful for a certain person. The task is to develop lighting comfort parameters system for improving the comfortable living of the older people. One of the experiments had a challenge to define which room color temperature is better. No, it's not quality of camera. It's 2 different pictures for 2 different color temperatures. 2600 Kelvin on the left and 4400 Kelvin on to the right. And the system uses following parameters. There are 3 input parameters: pulse transit time, illuminance, and correlated color temperature, and 2 output parameters: correlated color temperature and illuminance. So, therefore, how we could provide comfortable indoor staying? You can see on the right side a lot of types of photoplethysmogram. It's ideal photoplethysmogram picture A, and a lot of another with different noise corrupted signals. But there are 4 scenarios how to provide comfortable state. Scenario 1: it's informing a doctor or calling an ambulance and informing relatives when the system can make determination if a person has a good photoplethysmogram or it's big deviation. It's for example, it could be a problem with heart and so on. The second scenario is only improve the level of comfort. For example, system can see that the person is healthy, but the lighting is not so good we could be. Third scenario is improve comfortable level and only recommendation to visit a doctor in order to become some diagnosis and the recommendations. And scenario 4 is ideal signal, no any comfortable deterioration, no any healthy problems. So the second experiment was done by different together with different correlated color temperature, starting from 2500 kelvins to 9000 kelvins. You can also see a difference in these pictures. It's different correlated color temperature. Yes, lighting is not only way to see what happens around, but it's also healthy. It's also a way to impact on physiological state, on physiological state, and way to help the person in order to solve the healthy problem. And during the second experiment, it was also important to measure electrocardiogram signals during the changing of correlated color temperature. And before and after the experiment, each test person had to measure photoplethysmogram. So you can see some results of experiments here. Actually, here on the left side, you can see a picture which describes color temperature and the comparison of this color. And it was found that during the rising of correlated color temperature, it rises error interval. It's interval of electrocardiogram. It's decreasing heart rate level during the increasing the correlated color temperature, and the opposite situation. You can see in the right side which parameters is increasing and which parameter decreasing or increasing. So it's also important to take into account comfortable lighting for person. So famous Netherlands scientific Kruithof had at the beginning of 20th century found a certain curve which describes certain area of comfortable lighting. So it's important to stay in this white area. If it's red, this graphic describes illuminance dependence on correlated color temperature. If person stays in the red square, it's warm lighting and it's uncomfortable. If person stays in a blue area, it's called lighting. It's called uncomfortable lighting. So warm and cold, it's not only about room temperature, but also describes color temperature. Color temperature room, color temperature cold, color temperature warm. And it was, and I could approximate. This graphic was built by me. It's approximation of area of these areas. There are not only lighting parameters can impact on a comfortable level or healthy level, but also another microclimate parameters such as room temperature, humidity, and, for example, speeds and direction of air moving, clothes, and so on. So this system is yes, the main point was on in-addition lighting, but system can also take into account another microclimate parameters. So correlation between lighting and room temperature. You can see here a list of recommended light indoors. We are at the moment we are I think somewhere in the meeting rooms. So here's recommended brightness, recommended illumination, but main point I had to deal with office, and in office illumination is in the range from 200 to the 500 lux, and it's also was built graphic correlation between illuminance and room temperature in order to define which area of comfort working zone is better. As a result, it was received. Yes, it's the same Kruithof curve, but with comfort working zone. And one of the experiments was, and we had to deal with one of experiments in order to define if the test person agree or disagree with certain room temperature and lighting parameters. And you can see here some points where person does not agree with conditions. Since it's also comfortable zone, and as a result, it was we have become certain cube which describes the comfortable zone of illuminance, color temperature, and room temperature. Concept of room parameter control system. So there are three stages which system which system is doing. It's human healthy control. It takes into account users and biological parameters, and also takes into account users and mobile apps which person can regulate. The second one is edge level. It interacts with the cloud layer to protect information storage, processing, and analysis from predicting a person's pet health care. And the third stage is collecting data about microclimate parameters. It not only lighting, but also another microclimate parameters. So it was built main architecture of the systems of the system. You can see here 4 layers. It's presentation level, in which each of these levels has certain component, certain type of object, and certain responsibility. For example, presentation layer has client application, and And the responsibility is statistical representation, activation of the certain system devices, mechanisms for system control and configuration. The second one is cloud or server level. It has, as you can see, 4 different components, and it's responsible for different tasks such as authentication, authorization, data coding and decoding during the work, load balancing and message between the service, and different services such as analytic, artificial intelligence, big data, controller. The third layer is edge layer. It also has a lot of different. It also has a lot of different components, and it deals with receiving receiving transformation and information holding on a local level. It provides administration with the flexibility to store, and it also some another tasks. And the last one is device layer. Actually, it's more connected with process working. Especially, you can see it's divided in 2 blocks: sensors and actuators. Sensors in order to take into account certain parameters, and actuators which are realizing certain conditions which are responsible for output parameters. So I have already talked about certain scenarios. You can see it here instead of instead of the last when we have ideal conditions. It's starting. So we have got the certain algorithm. It starts. It takes into account data from PPG. It's processing it. Then we have got least square support vector machine. We have got human state evaluation. We predict the data. We are going to define of human system is defining human healthy conditions. And it's not only a way to process this, pre-process this data or process, but the system has also historical data, especially about the person, how old is he or she, did this person had earlier any chronic or bad problems with health, and so on. And system defines and also information about comfort zone data, especially in which building, in which room person is sitting. Because if you remember, for each room is certain recommended lighting parameters, and as a consequence, system makes certain scenarios. So it's you can see here representation of the variable data analysis platform, which analyzes user submitted data. And variable data, it helps to communicate between human sensors, especially it can be a typical fitness bracelet. It can be different sensors which people can use during the certain processes. And system and then the system can in each second define how does the person feel and so on. So as a result, it was projected certain electrical scheme. Actually, it's electrical scheme which is responsible for circadian rhythm regulation, and I took into account only lighting. You can see lighting output parameters as lighting, but input parameters are you can see here color sensor. It's taken into account lighting parameters such as illuminance and color temperature. And you can see here Bluetooth module system can receive through from the biological sensors through the Bluetooth module information about the person. And also I use a microcontroller ESP32. I use it because the system has three options how to work. The first one is to regulate to adaptive to the human healthy level, taking into account input parameters, taking into account the microparameters. The second one, person can regulate parameters as he or she wants. And the second and the third option, system can regulate microclimate parameters, but do not take into account human physiological parameters. So, and now I would like to show you the device. I don't know if you could maybe come here, or I can show it. Larysa, может трохи допомогти? I have done certain quasi, not so big. I have done have deal with certain prototype. It's only a little part of the whole system, which I have just shown. I use here ESP32. I use here Arduino Uno. I use here RGB sensor, and I also use here sensor which measures physiological parameters. Unfortunately, it's defect. I cannot now show how does it measure, but I can explain a little bit for better explanation. So we use ESP32 microcontroller because it has a connection with app Blink Yehor. It's app which is a mobile app which can construct another possible apps, and the person can see either through through the app about your personal state, about physiology, about photoplasmogram, for example. I mean heart rate, then and also regulate the lighting parameters as he or she wants. So and therefore I use ESP32 in order to connect with this app. So I also use usual Arduino Nano because it helps to do processing control work with certain list of sensors. I use here RGB sensor because it takes into account lighting parameters, which color temperature, which illuminance is here around. And as output parameters, I use RGB strip, which flashes certain light. It can be also a red light, it can be a blue light, different light as the output parameters. So, and conclusions. We have just presented a concept for the EOT system, which allows to define critical human health conditions for the older people. We presented approach for the intelligent lighted system for comfortable living of the older people development, and we suggested a medical parameter that allows to control the healthy and comfortable staying for the older people. Future work. Actually, Professor Globa has already told about the future cooperation. Yes, that's right. It's important to make research together with doctors about the human healthcare and definition of critical decrease in healthy level, because we have already done 2 experiments with lighting. The first one was only to measure comfortable level, lighting comfortable staying in the building. The second experiment is was realized in order to define changing of physiological parameters by changing the lighting. It's important to continue and improve the research about the human's comfort level. And it's also important to make the experimental research of the system functionality. And it's important to develop and test the prototype. Yes, it's also prototype, but it's only part of the big. It's only little prototype of the big prototype. Of the non-invasive wearable device for human healthy level control. And for future work realization, we would like to find the partners for this common project or join to the existing project. We are also ready to find some other ways of cooperation. And this is the system which can be, which takes into account a lot of different specialities. It also can be realized through the artificial intelligence. For example, if system can how system can define the age level of person, and another possible realization, and there are a lot of another possible realization for this system. So thanks a lot for your attention. If you have any question, please ask us, and we'll try to answer.
Okay. No more questions? Okay, I have just one question. I want say that the work is really interesting, and I think that you will have a nice dissertation next technical regulations. Do you have any publication of a scientific paper?
Yes.
For the oriented to the IoT research or the system, because I think that
I have certain publications.
And it's interesting enough to publish.
So I have a lot of publications connected with this topic. Unfortunately, I cannot show it in this presentation, but
it's just also for the students and for us to have a look at that in order to find also the ways of collaboration and more in-depth idea of the work. So we will have, probably you can share those publications with us in order to the publications or the links. And the other question is more technical. So you decide to use less square SVM classifier for the core analytics, the less square SVM super vector machine algorithm, the core of the analytics of your diagram flow. Okay.
one moment, I'll find this algorithm. It was earlier. Is it?
No, yeah, the question is why you decide to use this specific algorithm and not to check another kind of, because less square SVM is a nice classifier, but probably it's difficult to get a fine-tuned parameter for this kind of data, I guess. But probably, did you consider to use another kind of classifier?
Actually, no.
No.
But
because of recommendation of the system.
But I'll take into account this this opinion. I wanted.
Probably it's a question that
Huh?
some professor can ask you in your PhD dissertation.
Mm-hmm.
Why you decide to use this specific algorithm? What was the decision to do it? I mean, I think it's a good decision, but did you consider another one?
Actually, if, I didn't consider another. I thought how to realize, and in this case, I decided to use this way in order to how can I say, in order to with possibility to add another possible data set. And if in this case, actually we could also use another ways, but first of all, it was idea to use only training and validating data.
No more questions? Do you have questions in the chat or?
No, we don't have questions. I have one. How do you manage the private information? I mean, like the name of the patients, or you know that this kind of information is sensitive. So probably the patients are they don't want to share this kind of information, or join to this kind of, if you make a pilot, for example. So how do you collect this data and have this privacy of this data to train the data?
You mean age, for example, no, private?
You know that
Private.
these wearables, with this device, you obtain information from people, from specific people. And probably these people, they don't want to share this kind of data because they sensitive.
Actually, if we think over, anyway, doctors, I don't know how does it in Spain, but in a lot of countries, doctors, it's only dates for medical personnel because doctors know these dates about the person, and it's the first point because only certain responsible people know about this information. And the second, another question is security of this date. And actually, I have not thought about about the security realization.
But about the security, I can add this device should to get data and transfer via the open network. Okay. But for security, it needs to use specific techniques. And for example, traffic classification can be used. For example, our approach. And there are some approach for mixing data already, which can use already. It's need when develop whole system, it's need to take into account all architecture of the system and special zone for data transfer. This data should be transferred in cloud, but it's especially clouds building for health system, and this cloud has own defense body, has own techniques, and this is a very big question. And we think about maybe if we speak about the project, we can look at each part of this project of this system, because not only, for example, not only the data which discussed here possible to take into account. It's possible to take into account different data about this this person, about this patient for doctor. But doctor has possibility to take his data, via the system. It's need to think about big system, but the part of the system very important. What kind of the sensor can detect the critical situation with patient? For example, very bad for this person became very high pressure or something like this, and very high temperature or something like this. And it's need to consult with, if speak about project, it's need to consult with doctors about the number of the data which need to make the decision. Maybe something it's need to change, and to predict. It's possible to predict the bad situation. It's better to have that treatment before the insult, for example, than after insult. Its idea is for whole. And according to this, we think about maybe a complex project, maybe more big project than this one.
It's a prototype.
Yes, like
Consider
yes,
the whole
yes,
station,
yes,
but it's
yes.
also a
It
matter of-
needs to involve the people from medicine. We have in Ukraine, we have possibility to involve the medical professor from medical who has that. I know one of them very well, and this is idea was common idea. She has the woman. She has that possible to detect according to some parameters to detect that it's possible to be this parameter shows that in nearest time it's possible to be insulted, but it's very difficult device. It's need to the person should to come, and this is device very difficult for, and it's very good if come and they detect, but if not come, nobody detect. But if people who has such kind of diseases come has some all the time detected, for example, sensors like some of I doesn't know where it should be, and all the time, from time to time, system should to inform, and if detect some parameters, inform, and doctor can look and maybe possible to prefer the to not have the very deep conditions of the people. Some like this.
And
But if we speak about system, it's need in complex to look at this system.
And actually, I have already talked about different. It's also one of the examples. I have already talked about the different year categories, 21, 44, and so on. But it's not the last version. It was found in some literature. You can see it here, and it needs also more research, because what about the people until they're 21 years old? It's the first question. The second question is also, we don't know 60 plus, but it can be 100 years old. It can be only 61 years old. And it also needs more research in this case together with doctors. It's one of the remark.
So then, I think we can finalize the session. Also, can make some visits in the institute. I think that you also have to go to the center.
But
Administrative.
I need to close the online session.
Yes.
So, okay, we are going to close the online session. Thank you very much for attending and see you in the next one.
Okay, thank you.